Hello again. So, last time we left off on just getting to the 45, 45, 90 triangle, establishing the ratios of the sides. So, now that we know um, how we can sort of write out the lengths of these sides, let's go through a couple problems. So, this one, it says find the value of each variable. And of course, it's giving us a right triangle with a 45-degree angle. That, of course, means the other angle must be 45 degrees. And it wants us to find x and y. Now, y is the hypotenuse since it's opposite to the right angle. So that means x is a leg. And according to what we established earlier, that means x is going to have the same value as the other leg. Because since the angles are the same, it's isosceles, and these two sides will have the same value. And what we also know is that the value of y is just the length of the leg times the square root of 2. And that's literally it. That's all we have to do to solve for the sides in this problem. It's just that easy. So let's go through another one. Another two, I guess. So find the value of each variable again. So 45-degree angle here, 45-degree angle here. That means these two sides have the same length, so y is going to be 25. X is our hypotenuse, therefore x is the length of the side times the square root of 2. So it's 25 times the square root of 2. And we're not going to bother multiplying 25 times the square root of 2 because you'll just get some super long decimal. It's much more simple just to write it like that. Now, for a problem like 3, it's a little bit different, a little bit more complicated, but as long as you keep track of your work, it's not that bad. So this is 45 degrees here. This time, we are given the length of the hypotenuse. Now, like for instance, we know x is some value a, and so is y. X and y have the same value a, and the hypotenuse is equal to whatever that value of a is times the square root of 2. So we can sort of solve this like an equation. Now, I know that a times the square root of 2 is equal to 19. And I want to solve for the regular side a, the two legs. So to get a by itself, I could just divide by the square root of 2. These would cancel out, and we're left with a equals 19 over the square root of 2. But unfortunately, it's considered like improper, and like we don't want square roots in the denominator of our fraction. So there's a technique we use to get rid of them. I'm going to multiply by the square root of 2 over the square root of 2. That way, I'm technically multiplying by 1. Any value over itself is equal to 1. So I'm not changing the value of my answer. But when I multiply it out like this, we get 19 times the square root of 2 over, and when you multiply the square root of 2 times the square root of 2, that becomes the square root of 4, which, as we all know, is just 2. So our final answer is 19 times the square root of 2 over 2. That's the value for a, which is the value for both x and y. So again, just make sure if you ever have a square root or a radical in your denominator, to cancel it out by multiplying by that same radical over itself. So that is it for now. In the next video, we'll be exploring a new type of triangle, which comes with its own set of unique properties.